If you've ever hauled a bag of fertilizer from the trunk to the garden, you know the exact flavor of that moment. Awkward, dusty, and just a little too honest about your weekend plans. That bag is where Fritz Haber starts for me. And that's not where you'd expect a story about bread, war, and a Nobel Prize to begin. It turns out a lot of modern life is hiding in a brown plastic sack. Plants need nitrogen to grow. They need it for proteins, for DNA, for life itself. The problem is that the air around us is full of nitrogen, but plants can't use it in that form. For centuries, farmers leaned on manure, crop rotation, guano, and nitrate deposits dug out of places like Chile. Useful, yes. Limitless, no. So Haber, working in Karlsruhe in the early 1900s, tried to do something that sounds simple and is actually brutal. Take nitrogen from the air, add hydrogen, and make ammonia. Not literally from nothing, from air and hydrogen to be precise. Still, the goal was wild. He used high pressure, high temperature, and a catalyst to force the reaction into happening at useful yields. It worked! That's the turning point. The chemistry behind it is the kind of thing that makes you respect how stubborn molecules can be. Nitrogen gas is held together by a triple bond, and that bond is extremely strong. If you want to break it and get nitrogen into a form plants can actually use, you have to shove the reaction uphill with serious force. The catalyst helps by lowering the energy barrier. It doesn't magically change the destination. It makes the trip possible. That's the whole trick. A very expensive trick if you're doing it on purpose. Haber's lab work showed the idea was real, and then Haber-Bosch and the engineers at BASF turned it into something much bigger. That part matters, because a lab result is one thing. A continuous industrial process is another. Bosch had to build steel reactors, compressors, and systems that could survive enormous pressure without falling apart. He had to solve heat, corrosion, safety, and scale all at once. That's the moment chemistry stops being a school subject and starts becoming infrastructure. And once ammonia could be made that way, it helped reshape agriculture. Synthetic nitrogen fertilizer let farming rely less on finite nitrate deposits. It pushed crop yields up and helped reduce famine risk where food supply was tight. If you've eaten bread, pasta, rice, corn, or meat raised on feed grown with synthetic fertilizer, you've already touched a process that helped enable modern food production. Haber got the 1918 Nobel Prize in Chemistry for it, which feels right until you remember there is another half of the story coming next. That other half starts with war, because war has a way of turning useful chemistry into something uglier. During World War I, Germany was cut off from Chilean nitrates by the British blockade. The Haber-Bosch process didn't just help feed people, it also became part of the chain that kept nitrates flowing for explosives. Same chemistry, different ending. That's the first hard turn in the story. Haber himself stepped straight into the military side. He became a consultant to the German War Office and helped organize the first large-scale chlorine gas attacks. The infamous one at Ypres in 1915 is the one people remember, and for good reason. Chlorine is heavier than air, so when it was released from cylinders, it sank into trenches. It wasn't a battlefield weapon in the old sense of bullets and shells. It was chemistry weaponized against breath itself. That is the part that makes people go quiet. And Haber didn't see it as a contradiction. He believed, in effect, that science served humanity in peacetime and served the nation in war. That sounds clean when you say it fast. It is not clean when a gas cloud rolls into a trench. That creed is one of the reasons he still sits uneasily in history. He is often called the father of chemical warfare, and that title is not decorative. It points to a real shift. Chemistry became a battlefield tool on an industrial scale. The unsettling thing is that Haber's world did not stop there. His institute worked on toxic and pesticide gases, and that chemical path later fed into the development of Zyklon B, a cyanide-based insecticide that the Nazis later used in extermination camps. That is not a neat straight line from one man to one atrocity. It is a technological lineage, and those are often harder to reckon with than villains in a movie because they involve labs, factories, patents, governments, and the slow corruption of useful science into something murderous. And I also think Haber is more interesting than a cartoon version of him. After the war, he worked on things like combustion, adsorption, a fire damp whistle for miners, and a quartz manometer for low gas pressures. That detail matters because it reminds you he was not only a war chemist, he was a serious, restless scientist who kept looking for problems to solve. Then Germany's anti-Jewish policies forced him out, and he died in Basel in 1934. The country he had served so aggressively had no place left for him. The same science that helped enable modern food production can also become part of the chain that makes more explosives and poison gas. What do we do with a discovery that can feed a field and gas a trench?